Hey, knowledge lovers! Today we're exploring the best quantum physics courses on Coursera, from relativity and cosmology to quantum mechanics, particle physics, and the physics of the early universe. The links to access the courses will be in the video description. Let's dive in. 1. Exploring Quantum Physics, University of Maryland. This course gives you a lab-friendly doorway into quantum thinking. You move from the historical puzzles that broke classical physics to the core postulates of quantum mechanics: superposition, uncertainty, wave functions, and measurement, using approachable math and clear visualizations. Expect to see how experiments like the double slit and Stern-Gerlach force us to rethink reality. Hands-on notebooks, demos, and problem sets connect concepts to calculations, probability densities, expectation values, and basic operator algebra. 2. Understanding Einstein, the Special Theory of Relativity, Stanford University. Led by a Stanford historian of science, this course rebuilds Einstein's 1905 insight from first principles: simultaneity, the constancy of the speed of light, and the relativity of time and length. You will derive Lorentz transformations and see how they repair contradictions between Newtonian mechanics and electromagnetism. Rather than only grinding through formulas, the course ties the math to physical thought experiments, moving trains, synchronized clocks, and light pulses, so time dilation and length contraction feel inevitable, not mysterious. Expect graded quizzes that check both conceptual understanding and simple derivations. 3. Understanding Modern Physics 1, Relativity and Cosmology, the Hong Kong University of Science and Technology. If you want a bridge from special relativity into the large-scale universe, this first part sets the stage. You will review space-time diagrams, 4 vectors, and relativistic energy momentum. Then head outward to expansion, redshift, and the observational pillars of modern cosmology. Short videos and worked examples connect equations to telescope data, supernova distance ladders, the cosmic microwave background, and galaxy surveys. 4. Understanding Modern Physics 2, Quantum Mechanics and Atoms, the Hong Kong University of Science and Technology. Part 2 turns inward to the quantum rules governing atoms. You will develop the Schrödinger equation for canonical systems, build up angular momentum, and use hydrogen as a playground for spectra and selection rules. Practice problems emphasize setting up boundary conditions, normalizing wave functions, and interpreting expectation values. I pause here to mention that if you want to take all these courses, you don't need to pay for them one by one. Just by purchasing the Coursera Plus subscription, you will have access to all these courses and more than 7,000. We will leave you the link in the video description at the best price. Let's continue. 5. Quantum Mechanics for Engineers, University of Colorado Boulder, designed for scientists and engineers. This course focuses on usable quantum mechanics, band structure, tunneling, and nano devices. You will connect 1D potential steps and barriers to real components like diodes and scanning tunneling microscopes, and you will meet the tools of modern quantum tech. Problem sets walk you through approximations, matrix methods, and simple numerical solutions. By the end, you can read device papers with confidence and explain when quantum effects must be included in a design or simulation. 6. Particle Physics, an Introduction, University of Geneva. This course maps the Standard Model, quarks, leptons, gauge bosons, and the symmetries that organize them. You will see how accelerators and detectors turn fleeting collisions into plots, and how conservation laws guide event reconstruction and discovery claims. Lectures balance theory with experiment. Feynman diagrams for interactions, cross-sections, and lifetimes for what is measurable, and real analyses from colliders. 7. From the Big Bang to Dark Energy, the University of Tokyo. Here you follow the universe from its earliest fractions of a second to today. Topics include inflation, nucleosynthesis, structure formation, and the evidence for dark matter and dark energy. The course explains why each dataset, background radiation, baryon acoustic oscillations, supernovae, matters. Assignments emphasize model-to-data reasoning, fit simple cosmological relations, interpret Hubble diagrams, and understand error bars and confidence regions. Before we wrap up, here is a quick note on access. All of these courses can be taken without having to pay for each one, simply by acquiring the Coursera Plus subscription that offers more than 7,000 courses by only paying a monthly or annual fee. The link with the best price will be in the video description. Until next time, knowledge lovers.